All right. Today, what we're going to focus on is I want to look at applying the chain rule to some trig derivatives, some derivatives involving trig. So let's look at find the derivative for the following function. So we're going to start with y equals cosine of x minus 1. So this is my, what did I use yesterday? I used blue for my outermost function. Okay, I'm going to keep with that. So my outermost function is cosine, and my innermost function is the x minus 1. So I've got this x minus 1 nested inside of a cosine. So what's happening to x minus 1 is I'm taking the cosine of it. Y prime is going to be our outside derivative. So our derivative of cosine is negative sine of the inside function. So we're going to leave that as it is, x minus 1. Times derivative of the inside part. Derivative of x minus 1 is just 1. And so we just have negative sine of x minus 1. All right. Let's add a little later to it. So this is tangent of x squared. If it were the other way, it'd be tangent squared of x. F prime of x equals, derivative of x is 1. Plus derivative of tangent of x squared, well, we have x squared, and then what's happening to x squared? We're taking the tangent of it. So derivative of tangent of x squared, well, outside derivative, derivative of tangent is secant squared of the inside function. So the inside function is x squared. Times derivative of the inside part. Derivative of x squared is 2x. So to rewrite that a little bit, 1 plus, let's put the 2x out in front, secant squared of x squared. I just want to do one more off to the side so that you see what this looks like. If it were tangent squared of x instead of tangent of x squared, if it were tangent squared of x, now my tangent of x is the innermost function, and the outermost function, because this could be rewritten as tangent of x squared. So we have tangent as the inner function. What's happening to tangent is that it's getting squared. That derivative would be the outside derivative of the inside function. So the outside derivative would be derivative of x squared is 2x. So 2 times tangent of x times derivative of the inside part. Derivative of tangent of x is secant squared of x. So 2 tangent of x secant squared of x. So make sure you keep straight which is the innermost function, which is the outermost function. And work from outside to inside. Because now we're going to look at a chain rule happening inside of a chain rule. So in other words, on this problem, we have 3 different functions going on. we have a sine of 4t, and that is getting cubed. That's what sine cubed means. So we're going to build from outside to working inside. We're going to start with the cubed. That's the outermost function. And then work inside to sine. And then the innermost function is my 4t. So f prime is going to be, well, first we're going to deal with cubed. Derivative of cubed would be 3 times the thing squared. Well, what's that inside function? That inside function is the sine of 4t. Times derivative of the inside part. We want derivative of sine of 4t. So the outermost function there is sine. Derivative of sine is cosine of that innermost function 4t. Times derivative of the innermost part. Derivative of the innermost function. So derivative of 4t is just 4. So I'm going to simplify that real quick. I'm going to take this 3 here times 4 here is 12. And then I'm going to write sine squared of 4t cosine of 4t. So we're building from the outermost to the innermost. Let's do 2 more of these, where we have a chain rule nested inside of another chain rule. So again, I'm going to work with the outermost function first. F prime well, first let me rewrite this so that we can see what that outermost function is. So f of x is 7 minus cosine of 5x cubed. All taken to what power? Cube root means we're 1/3. So my to the 1/3 is my outermost function. Now let's do f prime. Equals. Well, my outermost function, derivative of going to the 1/3, would be 1/3 times the thing to the subtract 1, and we get negative 2/3. What is my inside part? My inside part is 7 minus cosine of 5x cubed. Times derivative of the inside part. Derivative of 7 is 0 minus derivative of cosine is a negative sign. But we're not done yet because we still have a function happening inside of the sine as well. Times derivative of the innermost part. The innermost part here is a 5x cubed. So derivative of that 5x cubed is going to be 15x squared. Right? So now let's take a look at simplifying this. Well, first off, this 15 here can cancel with this 3 here, and we're left with a 5. And this is going to get moved to the bottom, since it's a negative 2/3. That's going to get moved to the bottom. So on top, we've got a 5. We've got an x squared. And then we have this negative sign, which is going to be positive sign of 5x cubed. On the bottom, we have the 7 minus cosine of 5x cubed to the negative 2/3. So that's going to be a cube root of the thing squared. That's a 7 in parentheses. There we go.
Wait, so why do you apply you just take the 1/3 out of the equation by using the 15?
Because this is all multiplying. So that means that this 3 on the bottom can cancel with this 15 on the top. If you were to rewrite it with the 15 there, the 15 would be on top and the 3 would be on the bottom here. And you could reduce it. 15 over 3 would be 5 over 1. Questions on that one? All right, we're going to do one more of these. Chain rule nested inside of another chain rule. This one will be less complicated. Sine of cosine of 4x. So we are going to start with the outermost function. What's the outermost function here? It's going to be sine. So derivative of sine is cosine of the inside function. Times derivative of the inside part. So we want to take the derivative of this cosine of 4x. Derivative of cosine of 4x, well, derivative of cosine is going to be negative sine. But then we're not done yet because we still have this innermost function of 4x. So we need to multiply by the derivative of the inside part. Derivative of 4x is 4. So if you wanted to rewrite and rearrange here, we got a 4, there's a negative, and then I'll put a sine of 4x. Now we'll put it in this order. We'll do cosine of cosine of 4x. Times the sine of 4x. There we go. Yes?
So, on like a test, would we have to rewrite it?
I would get comfortable with rewriting this way. What I said in the notes yesterday is that what we simplify to depends on what we want to do with the problem. And so if we can help it be more organized, then it might help us answer questions like what's the domain of the function? Or where does the function not exist? Or things like that. Or you might get a multiple choice question where, say on this problem up here, you do the derivative and then you get this answer. This answer choice may not be there, but this one will, among other choices that look like it. So you'll have to pick out which answer does this simplify to. So being comfortable with seeing it rewritten in a few different ways is good. I would say this is good to rewrite, at least putting the -4 out in front so that we keep track of, oh, there's a negative from here and there's a 4 from the end there. All right, I'll put that homework assignment up there for. There. That brings us up to 2 homework assignments, but I want to do one more problem before we go. Find y double prime. In other words, find the second derivative of this function. Because this may not look like a chain rule, but once we do the second derivative, it will. Because what is the derivative of tangent? Secant squared. And now we need to do derivative of secant squared. So this equals secant of x squared. So we want outside derivative. Derivative of something squared is 2 times the thing. So 2 times secant of x. Times derivative of the inside part. Derivative of secant x. I want to go back and study these if you don't know. Derivative of secant x is going to be secant x tangent x. And so I'm going to simplify that a little bit. I have a secant x times secant x, so I have a secant squared of x. And then times tangent x. All right, questions on that? All right, that's all I have for today.